I will start the chapter Electrochemistry. Now, the first 15 lectures will be for both the higher secondary students and also for the chemistry honors students, and the remaining lecture from lecture 16 onwards, it will be solely for the chemistry honors students. So in lecture 1 I will give you the introduction regarding this chapter. So what is this term? This is electrochemistry. So you can easily understand that we are interested in the electrons of a chemical reaction. So with the help of the electron transfer that occurs within a chemical reaction, we intend to do something. Now electrochemistry deals with that branch of science which it is that branch of science which deals with the interconversion of chemical energy and electrical energy. So the branch of science, the branch of chemistry that deals with the interconversion of chemical energy and electrical energy is termed as the electrochemistry. So interconversion means there will be chemical energy to electrical energy and also electrical energy to chemical energy. Both will constitute this chapter. Now first we will focus on this part, that is transformation of chemical energy to electrical energy, and in the later part of our discussion, during the end of this lecture series, I will discuss with you regarding the conversion of electrical energy to chemical energy. Now, the vessel where this conversion takes place is referred as the electrochemical cell. That is, in an electrochemical cell, this chemical energy to electrical energy and electrical energy to chemical energy transformation takes place. So it is classified into two categories. One is the galvanic cell and another is the electrolytic cell. Now in this galvanic cell we have this conversion, chemical energy to electrical energy. So there is a spontaneous chemical reaction, a spontaneous chemical reaction that occurs within the cell, so that with the help of some technique, the electrons that is transferred from one reactant to another, so that reaction must be redox. So in a spontaneous redox reaction, the electron that is transferred from one reactant to another is technically taken out and is allowed to flow through an external circuit, so that we get electrical energy. Now with the help of that electrical energy, what will you do? You can run your smartphone, you can run any other electronic gadgets like digital clock, digital tablets, and the present generation, you see, cannot live without smartphone. It is not today at present, it is impossible to imagine life without smartphone, without any such electronic gadgets. So this discovery is a very vital one, and we see in the spontaneous redox reaction, the electron that is transferred from the higher electropositive reactant to the lower electropositive element is technically taken out and is allowed to flow through the external circuit through a conducting wire, and in this way we can convert the chemical energy, the stored chemical energy within the chemical compounds, to electrical energy. And with the help of this electrical energy we can run a lot of things like I have just mentioned. So you need galvanic cell. Now examples are the voltaic cell, simple voltaic cell, and other examples are, one important example is Daniel cell. Now this dry cell, this is also an example. Fuel cell, this is also interesting. So these cells give you electrical energy at the cost of chemical energy. Now for your smartphone you need this dry cell. This fuel cell has some other importance. This Daniel cell is a improvement from the primitive, that is the simple voltaic cell over the, so it has, after removing the limitations of simple voltaic cell, that is the primitive cell, we got the Daniel cell. And dry cell is used where there will be no aqueous solution, is used to run the smartphones, and the present day generation may even live without food but not without smartphones. So you need this dry cell, it is mandatory. So you have to study this chapter. It is very important and enormous application. And on the other aspect, we have electrolytic cell, where we apply electric current from an external source and we force a non-spontaneous reaction to occur. The reaction is non-spontaneous. But by applying an electric force, that is with the help of a direct current, we force the non-spontaneous reaction to occur, to happen, so that there is a chemical reaction. Obviously that is a redox one, and this electrical energy is stored within that system in the form of chemical energy. So this has also enormous application in industry, like some chemicals that are produced with the help of this electrolysis, NaOH, Cl2, and also in addition to the synthesis of some chemical compounds with the help of electrolysis, there are other importance also. Electro-refining is done. In metallurgy, you can see a number of metals is refined with the help of this electrolysis process, and also some metals are extracted with the help of electrolysis. So you see the electrochemistry that deals with both the conversion from chemical energy to electrical energy, from electrical energy to chemical energy, and this occurs in galvanic cell. So this is one kind of electrochemical cell, and this electrical energy to chemical energy, this occurs in electrolytic cell. Here a spontaneous reaction occurs. The reaction occurs spontaneously so that it gives you current, and here you have to apply the current so that a non-spontaneous reaction could happen in reality and you get the chemical energy. So these two are the divisions of electrochemical cell. Now primarily we will deal with this one, and at the end we will go to this section. But in the introduction part I will discuss the important terminology of both the systems. Now this is a redox reaction involving cell. So the electrochemical cell obviously involves a redox reaction. So let us take an example that is Zn plus CuSO4 reversible ZnSO4 plus Cu. So if we write the ionic form, it will look like so this is the ionic form. The difference between the molecular form and the ionic form is that this sulfate is not participating in the redox reaction. So it has -2 here, and here also it has -2. So I am writing only the skeleton which is participating in the redox reaction. Now you see, in this reaction zinc is undergoing oxidation by 2 steps, and this copper 2 plus ion is experiencing reduction by 2 steps. Now if we take a vessel and mix the 2 reactants, that is we take copper sulfate solution and we put zinc granules in it. We add zinc granules. What will happen? This reaction will spontaneously occur when zinc granules will come in contact with the copper sulfate, so that there will be corrosion in the granules and we will get deposition of metallic copper on those granules. Now since we are experiencing that there is an electron transfer associated with this reaction, can we adopt a technique so that this electron transfer does not occur directly, rather it occurs through a support of an external circuit? If we manage to perform this, if we manage to force this reaction to occur not directly, rather the electron transfer is engineered by an external wire, then we will be able to generate electricity from the chemical energy. So that is the motto of a galvanic cell. Now before studying the details of this chemistry, first we have to know some terms that are associated with this branch of science. Firstly, you have to know what is oxidation. You all know this, just some of you have wrong information, so I am going to rectify it. Don't remember oxidation by the older definition, that is addition of oxygen. Is the oxidation. No, don't remember this. Addition of oxygen does not guarantee oxidation. Since you see, if oxygen reacts with sodium, then this sodium will undergo oxidation and this oxygen will undergo reduction. So oxygen is oxidizing it. So you may say that addition of oxygen leads to oxidation. So this definition is correct for this example. Since when oxygen is reacting with sodium, sodium is getting oxidized to sodium plus. But what happens when this reaction takes place? When fluorine reacts with oxygen, what happens? What will happen? See, this zero oxidation state will convert like this. It will be -1, it will be +2. Now fluorine is more electronegative than oxygen, so it will extract electron from oxygen atom. So you see, oxygen is reducing in this case, is reducing fluorine. So addition of oxygen is no more an example of oxidation in this case. So forget this definition, that is addition of oxygen is oxidation and loss of oxygen is reduction. Rather, memorize the general definition and the realistic definition, which is the truth, that is loss of electron. Loss of electron is oxidation. Remember this thing. Any species which lose electron is said to undergo oxidation, and any species which gains electron is said to undergo reduction. So, if we take this example, what are the examples for this oxidation and reduction? This Zn arrow, Zn2 plus 2 electron, this is the oxidation half. This we say as half reaction or half cell reaction, since when we add both the oxidation and the redox part, that will give us the complete cell reaction. Now the reduction part for this example will be Cu2 plus 2 electron arrow Cu. So this is the another half reaction. The difference is, this is the oxidation half reaction and this is the reduction half reaction. Now when we add this, we will get Zn plus Cu2 plus arrow Zn2 plus Cu. So this is the cell reaction, the complete reaction. So you see that zinc is undergoing oxidation and copper is undergoing reduction. It is losing electron, it is getting converted from 0 to +2. So it is undergoing oxidation and it is gaining electron Cu2 plus. It is converting from +2 to 0. So it is the reduction part. So remember this thing, loss of electron is oxidation and gain of electron is reduction. Another terminology is that, the important terminology for this branch is that for this half reaction you need the half cell where a Zn rod is partially dipped in ZnSO4 solution. The zinc rod is partially dipped in the aqueous solution of ZnSO4. So this metal rod is the electrode. Now this external where we will use the current is connected to this solution with the help of this metal rod. So this is the electrode. Now electrode are of two types. One is anode and another is cathode. electrode has two division. One is anode and another is cathode. In anode, oxidation will occur. And in cathode, reduction will occur. Now don't remember the older definition again. Don't remember anode and cathode by the terminal sign. That is, anode is a positive electrode, anode is a negative electrode. Don't remember such things. Just remember, anode is that electrode where oxidation occurs. Electrode is the middleman which connects the conducting wire with the solution and helps in the electron transfer process from the solution to the wire or from the wire to the solution. Now these electrodes are of two types. One is anode and another is cathode. Now anode is that electrode where oxidation occurs and cathode is that electrode where reduction occurs. Now in the next lecture I will compare the sign of and the functions of anode and cathode in both the cells. That is, what is the function and sign of anode and cathode in galvanic cell and in case of an electrolytic cell. Stay with me.